All right, so today we're talking about a pretty standard item when it comes to talking about algebra or any level of math, and that is order of operations. Normally when you learn order of operations, you learn the please excuse my dear Aunt Sally, but I wanted to show you guys a different way to think of PEMDAS, order of operations, that use some different letters just to bring some different ideas into play. It's not that far off, but it's a little bit different acronym. And so the acronym is GEMS. And what GEMS stands for, and so you can make a little sentence up if you want to use it to remember it. But what GEMS stands for is kind of the same idea as PEMDAS with one kind of exception, one little difference. And the difference is that G doesn't stand for just parentheses here. What G stands for is all types of grouping symbols. Off the top of your head, you may be able to think, okay, I know parentheses are grouping symbols, but what other symbols are there? There's also brackets. And we'll see in some of our examples here, there's two other grouping symbols I want you to be aware of, and one of those is a radical sign. You may be saying, exactly what that looked like, but we'll get to that in a minute. And the last one I want to make sure you're aware of is actually the division bar. When you consider more complex operations with the division bar, there's actually kind of these, and I'll show you this in a minute, but there's kind of these invisible parentheses that go around your numerator and denominator. So there's different ways that grouping symbols can look, not just parentheses. The other ones stand for pretty much what you expect. E stands for exponents. So what order should we deal with operations? Grouping symbols first, then exponents, and I'm going to put in here or roots. Grouping symbols, you might be saying, wait, you just put roots in grouping symbols. Grouping symbols means it's just making you aware that this group is kind of high priority, what you need to take care of. Not that you actually need to take care of the square root. That comes under the E. The M stands for, just like in PEMDAS, stands for multiplication, and we don't there's just no D in here, but we throw multiplication and division together because they're the same operation, just opposites of each other. And then the S stands for subtraction or addition. Remembering that these operations, both the M and the S, both of those, you take care of those moving across your page from the left to the right. So these are guidelines, not necessarily requiring a great deal of understanding about how numbers work, but this is just your general guideline for how to simplify an expression. So I'm going to do one, and then I'm going to give you one, well actually three to try. So the simple I do, just a basic rules, and then we'll get into some more complicated one. I have one equation here where I'm going to evaluate this expression by substituting in 5. So 6 parentheses, I'm going to substitute the 5 in for n plus 2 minus 4. You may notice that when I substituted in, and I don't know, we've done a whole lot of this so far, I put it in parentheses, the number I plugged in. And that's going to become really important as we move on. So it's just a good habit to get into. So GEMS or PEMDAS tells me from here I want to do the grouping symbols. So I want to pay attention to what's inside the parentheses here and take care of that. So 5 plus 2 is 7. The next thing I want to take care of is the multiplication. So 6 times 7 is 42. And lastly, I only have one operation left. So 42 minus 4 is 38. So take a minute. I mean, this is basic review, hopefully, and try each of these three expressions. The thing about them is they all have the same numbers, but just to prove that parentheses makes a big difference, parentheses in different spots. So pause the video, and if you're ready to go, here we go. So that for letter A, the first thing we want to take care of is there's no parentheses, no grouping symbol, so we want to take care of the exponent. So 15 minus 5 plus 3 squared is 9. And now because we have multiplication, or sorry, no, addition and subtraction, we want to move from the left side to the right side. So 15 minus 5 is 10, plus 9 is 19. For the second one, we've got all our numbers grouped together, so we want to go ahead and simplify everything inside of the parentheses. So we're going to move left to right. So 15 minus 5 is 10. And I rewrite except for what the portion that I took care of, I rewrite the expression exactly as it is. Then I'm going to add together the 10 and the 3, and now 13 squared is 169. That might not be one that's right on the top of your tongue, or right off the tip of your tongue, but the last one here, grouped differently. 5 and 3 are grouped, so I'm going to do 15 minus, and then I have 8 squared. Notice the minus sign, just like we've seen when we don't have that 15 involved. The 8 is what's being squared, not the negative 8. So it's going to be 15 minus, and then 8 squared is 64. And 15 minus 64 should give us negative 49. So if you feel good about those, which hopefully you do, we're going to go on to some of those more advanced cases, or just places that PEMDAS doesn't necessarily explain fully. So the cases of invisible grouping. So these are my I-dos to show you some cases, and then you're going to try one that's a little bit harder. So invisible grouping occurs when we talk about, we have these fraction bar. Fraction bar is an indicator of invisible groups, that you want to do your numerator group together and your denominator group together before you actually move on. So for the first one here, we want to simplify the numerator. So 5 plus negative 16 is negative 11, and simplify the denominator. So 6 minus 3. Yeah, I don't think I meant to do that problem quite like that, but anyway, negative 11 over 3 is our final answer. So simplify the numerator, simplify the denominator. I think I meant to do different numbers, but that's okay. I think I meant for this to be a negative 9, but we'll go with it. Anyway, simplify the numerators, then simplify the denominator, or vice versa, and then worry about the actual division. So if it was divided evenly, we would go ahead and finish from there. With the roots, again, we don't want to necessarily take the square root first. That's not what we're saying when we say GEMS, or PEMDAS even, if we wanted to apply it there. We want to think of it as figure out what's the number in the square root, and then take the square root. So we want to simplify this 7 plus negative 3, negative 5 plus square root of 7 plus negative 3 is 4. And then now that we've got that number simplified, we can take that square root. So the final answer, simplified, that would be negative 3. So just a couple of cases where you don't necessarily see the parentheses, but they are there. They do exist. So this you do looks pretty intimidating compared to maybe the questions we just did, but take your time. Please pause, try it, think one step at a time. That's the important thing about order of operations. What's the next step? One step at a time. So I'm going to go ahead and draw in my invisible parentheses here. So where do I see things grouped? Well, the numerator is grouped, the denominator is grouped, and then everything inside the square root is also grouped. So what I need to do when I'm working through parentheses, you want to work on the inside parentheses, the most inner parentheses first, whether they're actually visible or not. So I want to simplify, and I'm going to actually take this down here and simplify it on the side here. I'm going to take negative 5 squared minus 4 parentheses 2, and simplify that first. So if I simplify order of operations here, exponent comes first. And negative 5 squared in the parentheses, negative 5 times negative 5 is positive 25. Minus 4, parentheses 2, parentheses 2. From here, what comes next? Well, I have these three numbers being multiplied together. So I can go ahead and multiply all those together, 25, and we're really treating this like negative 4 times 2 times 2, so that would be negative 16. simplified inside the square root would be the number 9. So I'm going to rewrite this now a little bit simpler. Negative 7 plus the square root of 9 divided by, and I'm going to go ahead and just take care of my denominator since it's just an easy one-step operation, and that's divided by 2. So we took care of our inside parentheses. Now we need to finish simplifying our numerator. So if we look at the numerator, still got these invisible parentheses around them. I need to take negative 7 plus, and then the next step was exponents or roots. So take the square root of 9, which is 3. Now I can add my numerator. Negative 7 plus 3 is negative 4 divided by 2. And my final answer, go ahead, now I can do the division. This is what I was talking about on the other problem. And the answer is negative 2. If you can do this now, this equation is actually a lot like something we'll see later on in algebra. Try third quarter or so. Fourth quarter. So hopefully you kind of walk through that step by step, but the most important thing is going one step at a time. What's the next step that has the priority?